You're testing a banking app that heavily utilizes Shadow DOM to render elements such as transaction history, notifications, and digital cards. Selenium WebDriver by default doesn't have native support for traversing the shadow route. Your scripts are failing to interact with basic components like buttons and labels. In this case, you're required to go beyond default locators. How would you restructure your approach to interact with elements encapsulated inside shadow routes?
Great question. I actually tackled a very similar scenario while automating a corporate banking dashboard. Their dev team had implemented Polymer-based components, especially for displaying transaction history and statement tabs, and those were deeply nested inside Shadow DOM. Initially, our Selenium scripts failed miserably. We couldn't locate elements, clicks wouldn't register, and the test cases constantly threw no such element exception. So, the first step I took was understanding why Selenium couldn't access these components. Turns out, Shadow DOM encapsulates its elements, so traditional find element won't see them unless you pierce the shadow root boundary. Here's how I approached it. We started using JavaScript execution via Selenium to access the shadow root and traverse through its children. It wasn't just one level. In many places, there were multiple layers of nested shadow roots. To make this scalable, I built a custom Java method that navigates through the DOM using a defined path of shadow hosts. For example, I'd first locate the outer component, call getShadowRoot, then the next child inside, and so on, until I reached the transaction row or the download button. We also documented reusable shadow element paths for every page module, so we didn't need to rewrite traversal logic every time. The key lesson: with apps built using web components, your automation strategy must evolve. It's not enough to just use Selenium. You need to combine it with JavaScript execution and thoughtful DOM analysis to make automation robust.